So what we're going to do with long division is we're going to set up the problem just like back in the day when you were really little and you learned how to long divide for the first time. So x minus 2 goes on the outside, and then underneath the division is going to go our polynomial. What? Yes. But that doesn't mean you can take a nap right now. But yes, I will post this. Okay. So, x minus 2 on the outside, and underneath the division bar is the polynomial we start out with. And then we're going to ask ourselves, how many times does x go into x to the 4th? X cubed. So you're going to line your x cubed on top of your x cubed term. Okay? So again, x goes into x to the 4th, x cubed times. And you're going to take this x cubed and you're going to multiply both of these pieces. X to the 4th minus 2x cubed. Okay? And then what we're going to do with this is just like long division, we're going to subtract. So we're going to change the signs of both of these guys. Our x to the 4th cancel out. 3x third plus 2x cubed is going to be 5x cubed. And then I'm going to drop this down. Negative 6x squared. Okay. Then we ask ourselves, how many times does x go into 5x cubed? How many times? Okay. Plus 5x squared. Multiply both terms by 5x squared. Minus 10x squared. And then we go through and we change the signs. Subtract this one. We're adding this one. Oh. Our 5x cubes cancel out, and we're left with 4x squared. Bring down the 5x. How many times does x go into 4x squared? Plus 4x. So 4x squared minus 8x.
Where'd you get the minus
4x times negative 2. That's where I get the negative 8x. And then we go through and subtract again. Change this sign, change this sign. 13x minus 7. Oh. How many times? Nigel. That's great, Nigel. How many? So what do I need up here? How many times does x go into 13x? Plus 13? 13x minus 26. Subtract. Change the signs. Here's my remainder. Plus 19 over x minus 2. So we're going to set it up. X plus 3 on the outside. And then under the division bar, this one is a little trickier because there are terms missing. Right? There's no x cubed. X cubed goes here. There's no x. So in order to keep ourselves organized, what we need to do is we need to add in zeros anywhere we don't have a term. So 2x to the 4th. Do we have any x to the 3rd powers?
No.
No, but we need that placeholder, so we're going to go plus 0x cubed.
Can you do minus 0x?
Sure, if you want to. Next one is minus 20x squared. Do we have any x terms? No. So you're going to add another 0x in there. Plus 12. So again, we need these two in order to keep our placeholders in the right spot. Okay. And then we go through and we're going to ask ourselves that same question over and over again. How many times does x go into 2x to the fourth? 2x cubed. Whoa, I have it in the wrong spot. I need it over the top of my x cubed, otherwise I'm going to end up with a mess. 2x cubed. 2x to the fourth. 2x cubed times 3 is plus 6. And then we need to subtract everything. Our 2x to the fourths are gone. We end up with negative 6x cubed. Bring down the 20. Okay. How many times does x go into negative 6x cubed? Negative 6x squared. Negative 6x cubed minus 18x squared. Change the signs of both of them. Negative 2x squared. Bring down the 0. How many times does x go into negative 2x squared? Negative 2x. So negative 2x squared minus 6x. Change the signs. 6x. And then it's going to go in 6 times. 6x plus 18. So then our remainder is going to be positive 6 or negative 6? Negative 6.
6x plus 3.
Negative 6 over x plus 3. So again, all of the numbers that show up in our long division problem show up in our box. It's just, again, however you like to organize the information will work. I have one more method I'm going to show you, and that is called synthetic division. And I think you're going to like this one the best. And we'll start with the problem that we had before. X to the fourth plus 3x cubed minus 6x squared plus 5x minus 7 divided by x minus 2. And the way synthetic division works is we're just going to focus on the constant terms and how many times it's going to go into, sorry, we're going to focus on negative 2 and how many times it goes into the constants in front of our, the coefficients in front of our polynomials. So what you do, this is one of those very bizarre, abstract kind of math. You take this negative 2, you turn it into a positive 2, and you put it in a little box. And then the next thing you do is you take all of the coefficients from the polynomial. So the coefficient in front of the x to the fourth is just a 1. Coefficient here is 3, -6, 5, and 7. -7. I took all of the coefficients in front of my x terms. And then you also need to flip the sign. So you see how we have a -2 here? This should be opposite sign. And the reason why you flip this sign is because it takes care of the whole subtraction that we were having to deal with in the long division. So if you flip this sign, then all you have to do is add the numbers. Okay. So the way this works is whatever term comes first, you're going to drop this down right here. It's very weird. You're going to take this number and you're going to multiply it times 2. What's 1 times 2?
2.
2. That goes here. So again, what I did is I multiplied by 2. And then I add these two together. What do I get?
3.
Add them together. 5. And we take this 5 and we're going to multiply this 5 times 2. 5 times 2? 10. Add them together, I get -4. Oh no, +4, sorry, +4. You take this 4, you multiply it by 2, I get 8. Add these two together, you get 13. Take the 2, multiply it by 13, 26, 19. And what these are the coefficients that are going to be in front of my answer. So you start with one lower power. So if we have x to the fourth up here, our first term is going to be x to the third. Our coefficient is going to be 1. Plus 5 x squared plus 4x plus 13, and then our remainder is 19. So this one is synthetic division. And again, the only thing we're doing is we're just focusing on the constants and the coefficients